Hello everyone. We in this lecture we will discuss about the equilibrium of forces with some examples and problem solving. Um, Equilibrium of forces means the net force acting on the system is zero. So sum of forces equal to zero or net force equal to zero. If you have forces in two dimension in plane, so what we do is this is x-axis, this is y-axis. So sum of the forces along x equal to 0 and sum of the forces along y equal to 0. So for the equilibrium of forces, we need to see forces are balanced in all directions. So that we do with a coordinate system, a Cartesian coordinate system. Sum of forces along x and sum of forces along y equal to 0. Okay, this is a problem that find the value of T and R if the man of mass 80 kilogram is in equilibrium. T and R means T is the tension in the string and R is the normal reaction force of the wall on the person. So there are forces acting. T is the tension in the string, W is weight of the person, and normal reaction force. Um, this is said that T and R are calculated and the mass of the man is given to you. So we consider in this system the man as our object. So in every system you may consider a single particle as your point of consideration, and then what you are supposed to do. Number one, you are supposed to identify the forces acting on the man because our consideration is on the man. So there are three forces acting on the man, that is gravitational force of earth on the person and tension on the string on the man and normal reaction of wall on the man. So first thing is to identify the forces, and the second thing is to draw the free body force diagram. So free body force diagram is a vector diagram that represents all the forces acting on a single object in a system. So for us, we are considering the man, so we will draw the free body force diagram for the man. So I show you different forces over here. So what you are supposed to do to represent the forces in the correct given direction. We can see the W and R are correct in first case, but T is not correct. In this case, T is fine, W is fine, but R is not in the correct direction. W is fine, T is not in the correct direction, although R is fine. So here T is correct, R is correct, W is correct. So this is the correct free body force diagram. No, not this. So this is the correct free body force diagram. The animation is actually at a wrong place, so you may um, omit that. So this is the correct one which I'm writing, but when you get actually um, the video, then it also shows the other one, this one. So but that's not the free body force diagram. Okay, now the third step. Now you need to resolve the forces into rectangular components on a Cartesian coordinate system. So this is our Cartesian coordinate system with x and y axis at 90 degree to each other. So we represent according to that. The string is making an angle of 18 degree with the vertical. So of course the other angle is 72. So it's up to you that you can consider either um, the 72 or the 18. So in both ways it works. So this is t sine 72, t cosine 72. The other forces R and W, you don't need to make the components because they are already along the axis. So any other force that is along the axis, you don't need to change it into components. So here we can write sum of the forces along x direction must be equal to 0. Why we say that? Because the system is in equilibrium, and when the system is in equilibrium, sum of forces must be equal to 0. So sum of forces in x direction, sum of forces in y direction must be equal to 0. So positive x direction is r, so I can write r plus minus t cosine 72 equal to 0. That means t cosine 72 equal to r. Similarly, sum of forces along y direction equal to 0. So I can write t sine 72 equal minus w equal to 0. So t sine 72 equal to w. So we have this equation and that equation. You are supposed to find both t and r. So you can see from the second equation we can find the value of t. T is w over sine 72 degrees, and whatever the answer you get, this is 80 into 9.81 divided by sine 72 degree. So you will get an answer here over here. So I can calculate that this is 80 multiplied with 9.81 and divided with sine 72, sine 72. So I get 825.18 Newton, and then use this over here to find R. So R is equal to 825.18 into cos 72. So this number multiplied with cosine 72, that's 254.99 newtons. That can be written as 255 Newton. Okay, the next problem. What is the tension in each string if the weight of the picture is 50 Newton? So there are three forces that act. One is the gravitational force of the earth on the picture, tension in one of the string, tension in the other string, and alpha is the angle that picture makes over here, that's 30 degree. Now you draw the free body force diagram, you can see, and now the tension could be resolved into components. This is t cosine alpha and t sine alpha. Similarly for the other t, t cosine alpha and t sine alpha. Now sum of the forces in the vertical direction must be equal to 0. So I don't need to take actually the sum of the forces in x direction because there is one unknown only and one equation is just enough to solve it. So t sine alpha plus t sine alpha minus W equal to 0. So if upward direction is positive, downward is negative, so W is negative. So I can write 2t sine alpha minus W equal to 0. So 2t sine alpha equal to W. So t is equal to W over 2 sine alpha. So W is 50. 2 into sine 30. So sine 30 is 1 by 2. So your answer is 50 Newton. So in each string there is a force of 50 Newton. Keep this in mind that if the angle is 30 degrees, so everyone feels actually the force of 50 Newton. Find the angle for which the tension in the string is the minimum. So the situation is still the same. Alpha is this. So from the previous problem, we found that T is equal to W divided by 2 sine alpha. You can see the value of the T depends upon the sine of alpha, and when sine of alpha is maximum, T will be the minimum. So for T minimum, sine alpha should be maximum. Maximum value of the sine is 1. So sine alpha should be 1. That means alpha is sine inverse of 90 degree, and that is equal to 1 alpha is, sorry, sine inverse of 1, that is 90 degree. So alpha needs to be 90 degree. It means if you have a picture and make the strings in this way that they make an angle of 90 degree, then the tension is minimum. So we can also calculate what is the minimum tension, that is W divided by 2 into sine alpha is 1, that's W over 2, which is 25 Newton. So in this case the every string has the value of 25 Newton, so the weight is distributed. But at 30 degree you have seen that every string actually experience a force equal to the weight of the picture. The next problem, find the tension in the string and normal reaction of surface on the man in equilibrium given that T is at an angle of alpha, that is 40 degree, with the horizontal, and T and N are perpendicular to each other. So there are again three forces: tension in the string, normal reaction force of the rock on the person, and there is W. So first thing is to realize the forces, and these are these forces, and it's said that T is at an angle of 40 degree. So this is 40 degree, and T and R are at 90 degree. So of course this should be 50 degree. So now this problem could be solved by dividing T and R into the components. So I can say R cosine 50 and R sine 50. Similarly, T cosine 40 and T sine 40 degree. So we can write two equations, one along x, one along y. So sum of the forces along x direction equal to 0. I can write r cosine 50 minus t cosine 40. So r and t both are unknown, so we cannot further go with this equation, but I can simplify this as t cosine 40 equal to r cosine 50. That I call equation number 1, and similarly along y direction equal to 0. So r sine 50 plus t sine 40 minus W equal to 0. So I can rearrange this as T sine 40 degree equal to W minus R sine 50. So now you need to solve simultaneously these two equations. First divide them with each other, t will be cancelled and you will be able to get value of r, and then use the value of r in any of the equation 1 and 2, you will get the value of the t. Okay, this you need to complete. I show you that this problem could be solved in a different way and in a much easier way also. So the same problem, same free body force diagram. What I'm gonna do is I change the axis. So I rotated the whole axis in this way. So x goes over here and the y also. The angles we have, this is 40, um, this is 50. Okay, so that's also 50, and you know um, that both dotted lines are 90 degree to each other. So if this angle is, this is 40, so that's equal to 50 degree also. Okay, so we change our coordinate axis. So now I don't need to make components for r and t. I'll make components for w. So I write w cosine 50, w sine 50. So now sum of the forces along x equal to 0 means r minus w sine 50 equal to 0. So r is equal to w sine 50. So here just put the value of w, that is 80 into 9.81 sine 50, you will get an answer for that. And sum of the forces along y direction equal to 0. So I can write the t minus w cosine 50 equal to 0. So t is w cosine 50. So here you don't need actually the simultaneous equations to solve. So just from 1 and 2 you can get the value of r and t, and that you can calculate with the help of calculator. So sometime we try to solve the problems in a more smarter way, but still if you like and the longer method, then that's perfectly fine. So it could be solved in two ways. So I mm, I explained the both the ways, and now what you are supposed to do is to find answers from both ways and see whether do you get the same answers or not. So this problem, first draw the free body force diagram. So I'm not explaining this, but you are supposed to understand it. I solved it already for you, so you are supposed to understand it. Now this athlete has been trained in this way, that a mass of 25 kilogram is being dragged at a uniform speed. Uh, it exerts a force F, and this is said that once the load is moving at a steady speed. That's important. So when the forces are balanced, so either an object is in the state of rest or it could move with a steady speed. So first thing is to draw the free body force diagram. One is weight, other is the normal reaction. and there is a tension in the string, and there is a force of friction. So this is at an angle of 25 degree. So I can say T cosine 25 degree, T sine 25 degree. Um, so sum of the forces along horizontal equal to 0. That means T cosine 25 degree minus F equal to 0. Small f is used for the T or F is the same actually. Tension in the string or force exerted by the. So here we can find T, that is F divided by cos 25. F is 470 is given here, and cos of 25, that you can calculate how much is T. Sum of forces along y equal to 0, that is R plus T sine 25 minus W equal to 0. So R is equal to W minus T sine 25. So here you are not asked to find T actually, but to find the value of R we need T. So we found first the value of T. W is 25 multiplied with 9.81 minus T sine 25. So put the values and get the answer in Newton. What about the inclined planes? So here this inclined plane is at an angle of 20 degrees, and this force is at an angle of 30 degree. There are other forces also, W, normal reaction, and a friction force also. Because this is being dragged upward and with a constant speed. So constant speed means the forces are balanced. So we do the same thing here. We consider our coordinate axis along the plane and perpendicular to the plane. Normal reaction is perpendicular to the plane. So we need to divide the forces T and W. 20 degree, the angle of inclination and angle between W and the perpendicular to the plane is always the same. So this angle is same as the angle of inclination. So I divide W cosine 20, W sine 20, and T cosine 30 and T sine 30. So sum of forces along x direction equal to 0. So I can write T cosine 30 minus W sine 20 minus 25 equal to 0. So T is equal to T cosine 30 is equal to W sine 20 minus 25. So T is equal to W sine 20 minus 25 over cos 30 degree. So T you can find from here, and if you put the values, you get 38.55. You can double check this value. I calculated in high, and so sum of forces in y direction equal to 0 means R plus T sine 30 minus W cosine 20 equal to 0. So now you are supposed to find R. So R is equal to W cos 20 minus T sine 30. Using the value of W and T calculated earlier, so you will get R as 3.77 Newton. Please double check this. If you find any issue, then you can get back to me. So hope this explanation is enough to understand the equilibrium of the forces. So there are certain steps to follow. Realize the forces present, then make the free body force diagram, make the components, and use if the equilibrium sum of forces in x direction equal to 0, sum of forces in y direction equal to 0, and then solve the equations. Okay, so I stop here with this explanation. Have a good day. Bye bye.